Hi everyone, welcome to the next video on the Desmos Scientific Calculator. This is going to be another Math 102 only video, and it's going to be another confidence interval walkthrough. So again, I'm going to go through the problem. I'm not going to focus on the formulas or understanding so much. I'm just going to kind of focus on how everything goes into the calculator. So I recommend that you get kind of a good grasp on understanding how confidence intervals work and how they work with proportions before you watch this video. But right, this will hopefully help you guys understand how everything has to go into the calculator and help minimize kind of mistakes. So the problem that we have here is that Daniel wants to estimate the percentage of people who play sports. He surveys 360 individuals, finds that 75 play sports. Using the empirical rule, construct a 68% confidence interval, round to 2 decimal places. So great, we're going to be doing a confidence interval, right, for proportions, right? Proportions and percents are basically the same word, right? So he wants to estimate using percents, so we're going to use percents. Right, the first thing I want to do is I want to find out the percent that he got in his experiment, right? In his experiment, what percent of people played sports? Right, and this percent is normally called my P, right? So to find that, right, whenever I'm finding any percent, it's always the part that I care about. So today it's 75 people I care about divided by the whole, the total, divided by 360 total. And I see I get this decimal for the percent that played, and this is my P, right? And I might normally write this down as 20.83333%, right? But I know that as a decimal, this is actually how it's written. So great, I have my P. The next thing I might want to do is find my standard error, right? And standard error is a little bit different in these proportions problems, right? Just for percents, we have kind of this special formula that standard error is equal to the square root of this fraction, which is P times Q divided by N, right? And Q, by the way, is the percent of people who didn't play sports. So I could calculate that using these numbers, or sometimes you see this formula written, that it's the square root of P times 1 minus P divided by N, right? Because 1 minus P and Q, that's the same thing, right? These are the percent of people who didn't play sports. So great, on this next line, I'm going to try to actually plug in, and I'm going to use this second formula so I have less things. But my standard error is this fraction where I have my P, so I will copy that. Right, and I don't want to round, at any point. I want to make sure I'm using all of my decimals until the very end. So I have P times 1 minus P divided by N. N is the number of people who are in my experiment. And if I look around here, right, he surveyed 360 people. So 360 is my N. And here I have my my standard error, right? It calculated it for me. It's really small because I surveyed a lot of people, and that really reduces my error. The next thing I have to do is I have to find my margin of error, which just like before, my margin of error, right, which is the same thing as error-bound margin, right? Sometimes written both ways. My margin of error is still, it's Z, the Z that I have to use times my standard error. Right, which is the same thing, of course, as standard error times Z. So I'm going to do it that way because I already have my standard error done right here. I have to do times Z, and I have to think, what is the Z that I'm supposed to use for this problem? Right, well, it all depends on the percent of the confidence interval, right? And for 68%, I have to have memorized from the empirical rule that 68% goes with the Z-score of 1. Right, so I'll say times 1. Right, but depending on this percent, I might have a different Z-score. I might have a Z-table where I have to look up my Z-score, right? But whatever the Z-score is I'll use for that problem, I'll multiply right here to get my margin of error. So here I have my margin of error. It just so happens to be the same as my standard error, just because I multiplied by 1. That doesn't always happen, but today it did happen. Right, and then next, I can finally put together my confidence interval, right? So it's going to be P, which is the percent that I got, minus the margin of error, and then the other side will be P plus the margin of error. So I'll do this on 2 different lines, right? First I want to go get the percent that I got, which is right here. And I have to do minus my margin of error. My margin of error was right here. And it spits out my lower bound for my confidence interval. And then I want to do the same thing with a plus. I'm just going to copy paste this and change my minus sign to a plus sign. That's the only thing I have to change. Right? And then I want to be careful because this is a percents problem, this lower number up here, I wouldn't normally write it like that, right? I would normally write that as 18.6929118%. Right? And you'll remember I can't just have a plain percent sign on Desmos, but right, it's 18% and 22.97%. So when I round these, I want to first turn them into percents, right? And say I'm going to round this, and I actually have to round 18.6929118 to 2 decimal places. And then when I do my other bound, right, I don't want to round just this number, right? I want to first turn it into a percent, which would be 22.97 blah, blah, blah percent. And I'll put a 2 here for 2 decimal places. So just to show you guys, I'll type it out in Word where I can type it nicely. My final answer here would be 18.69% to 22.97%, right? I have to be sure that I convert these back into normal percents because this is how we use percents in real life. But that is how I would go through one of these problems on the calculator, right? These are all the different formulas I'd use and the way that I'd use them.